Welcome to Study Loop.
The point 2, negative 1, called P, lies on the curve y equals 1 over 1 minus x. We know that is true because if we put x equal 2 in this equation here, we get y equals negative 1. So the point 2, negative 1 lies on the curve y equals 1 over 1 minus x. In part A, if we take any point of that curve q, that is with coordinates x and 1 over 1 minus x, we want to calculate the slope of the second line PQ for the following values of x: 1.5, 1.9, 1.99, 1.999, 2.5, 2.1, 2.01, 2.001. That is, we are taking values closer and close to 2 from the left and from the right. In part B, we're going to use the results in part A, and with that, we're going to guess the value of the slope of the tangent line to the curve at P 2, negative 1. We know these slope will be the values that are approaching those slopes of the second lines. In part C, we use the slope guessed in part B to find an equation of the tangent line to the curve at 2, negative 1. So we're going to calculate in part A all the values. So first, we note the following. We're going to write the slope of the second line through the points P 2, negative 1 and Q given by x 1 over 1 minus x, supposing x is not 0. Sorry, x is not 1, which is the value that nullifies the denominator and the value is undefined. So if we write that slope of that second line, we get the following, called the slope m, and we know the equation will be 1 over 1 minus x, which is the y coordinate of the point Q, minus the y coordinate of the point P, that is negative 1, minus negative 1. And in the denominator, we get the first coordinate of Q, that is x, minus the first coordinate of P, that is 2. And this gives us 1 over 1 minus x plus 1 over x minus 2. And in fact, this is equal to 1 minus x as denominator in the numerator, and 1 minus x denominator, and in the numerator we get 1 plus 1 minus x, which is 2 minus x. In the denominator of the big fraction, we get x minus 2. And then this is equal to 2 minus x over the product of 1 minus x times x minus 2. And we notice that in the numerator we can get a common factor negative 1 out, and then this negative parenthesis x minus 2 over 1 minus x times x minus 2. And because x is, if we take x different from 2, for example, and in this case we verify, we are not taking the value 2. We are close enough to 2 where we are never taking the value 2. So we can say that this is equal for x different from 2, that we can simplify the factor x minus 2, and we get negative 1 over 1 minus x, or in fact 1 over x minus 1. So the slope of the secant line PQ is m equal 1 over x minus 1. So this is our expression here. And now we can calculate all these slopes for x equal 1.5, which is the first value here. We get then the slope 1 over 1.5 minus 1 is 1 over 0.5. Remember 0.5 is 1 half, so it's equal to 2. Now part 2, we take x equal 1.9, and for 1.9 we get m equal 1 over 1.9 minus 1, which is 1 over 0.9. And here we use the calculator and we find that this is approximately equal to, and we are going to use 6 decimal figures, so it's 1.1 in all the decimals. So this is the slope of the secant line PQ at x equal to 1.9. Now part 3, we take 1.99, and so the slope of the secant line is 1 over 1.99 minus 1, which is 1 over 0.99, and this is approximately equal to 1.010101. Then in part 4, x is 1.999, and then we get m equal 1 over 1.999 minus 1, which is 1 over 0.999, and that's approximately equal to 1.001001. Now part 5, we use x equal, we did this already, we take 2.5, and so m is 1 over 2.5 minus 1 is equal to 1 over 1.5, and this is approximately equal to 0.666667. Then part 6, x is taken equal 2.1, m is 1 over 2.1 minus 1 is 1 over 1.1, and that's approximately equal to 0.909090, and not 0 because the following decimal will be a 9, so we take 1 here. And part 7, x is equal to 2.01, and so m is 1 over 2.01 minus 1, which is 1 over 1.01, and that's approximately equal to 0.99099. So this is 7, now 8, x is 2.001, so m is 1 over 2.001 minus 1, which is 1 over 1.001, and that's approximately equal to 0.3 times 9, 0.001. Okay, so these are our approximations, and we see that we have first approximations of x closer to the value 2 here, but from the left is all these result up to here, and for values of x closer to 2 but from the left, the value of the slope of the secant line PQ are getting closer and closer to 1 with values greater than 1. Now the other part here is for x closer to 2 but from the right. And for those values of x closer to 2 from the right, again, the values of the slope of the secant line PQ are closer to 1 again, but now from values less than 1. But in both cases, we see that the slope of the secant line PQ are getting closer and closer to 1. So in part B, we can say that the slope of the tangent line, which is in fact the limits of this or the values that are approaching these slopes of secant lines when we are close to x equal to, slope of the tangent line to the curve at p2 negative 2, because here we have a first coordinate equal to 2, which is the value we are approaching for the variable x. And when we approach the x to 2 from the left and from the right, the values of the slope of the secant lines approaches the value 1. And so we can say that the slope of the tangent line, which is defined as those limits, which get to be equal, in fact, from the left and from the right, and then we say that that slope of the tangent line to the curve at that point to negative 1 is 1. And in part C, we know then that the line, this tangent line, has an equation of the tangent line to the curve at p to negative 1 is given by y minus negative 1 using the coordinates of the point equal to slope calculated by using the slopes of the secant lines when x is approaching the value 2, 1 times x minus 2. So we get y plus 2, y plus 1, equal x minus 2. And if we put all from to the right of the equation, we get x minus y minus 3 equals 0. So this is the equation of the tangent line to the curve at p to negative 1. And we have calculated the slope of the tangent line to the curve at that point p to negative 1 using the slopes of the secant lines to the curve, fixing the point p to negative 1 and moving the point q by changing its first coordinate x and putting it closer and closer to 2 from the right and from the left. And in both cases, we have seen that the slopes of those secant lines approaches the value 1. So the slope of the tangent line will be 1. And with that, we have calculated the equation of that tangent line at the point 2, -1.